everyone. I hope you're ready because today Bill Brunt is about to open the curtains and give you his take on SharePlex like never before. Welcome to SharePlex Unveiled, where we'll explore how this powerful yet often overlooked tool is transforming the way organizations move, scale, and leverage their data. Get ready for an eye-opening session packed with insights that could change the way you approach your data strategy. Let's dive in.
This is the Skills 101 series for SharePlex. Today's episode is Discover the Power You Didn't Know You Had. My name is Bill Brunt. I'm a software sales engineer for Quest Software. Today we're going to be going over who this presentation is intended for, what is the value of replication provided by SharePlex, what is replication itself, and then we'll do a little bit deeper dive into each of the use cases, go into the differentiation of SharePlex compared to other solutions, and finally wrap up with some Q&A. Let's get started. So who uses SharePlex, or who is this presentation for? It's really for any of these folks. And it just comes down to whether you have either responsibility and or influence for a database. So you might be an architect, a business application owner, DBAs, management, data scientists, some really exciting things in terms of the field of AI that we're doing with replication. So this particular episode is the broadest possible coverage for SharePlex, and subsequent episodes will go into greater detail. Let's talk about the power of replication. So at a high level, we've got four main use cases. The first I'm going to talk about is AI ingestion and how SharePlex helps with this. Best way I can summarize it is think about giving AI the instant replay. Then I'm going to talk about scalability and how replication gives you options for very consistent response times and unlimited scaling with really commodity hardware versus really high end. And then we'll talk about high availability for both planned and unplanned events. And finally, the last use case is data integration. So I'll give you some idea of all the ways that SharePlex can move data. So to start with, what is replication? So the dashed line going up and down the middle of the screen is simply dividing between a source database on the left and a target database on the right. You install SharePlex and it begins to capture incoming transactions. It does this from either Oracle or Postgres by reading the online redo or wall logs. Now, once we see a change which has been written to the database, we turn these into change messages. And for highly optimized, efficient message transfer, we've actually using a combination of both TCP/IP and UDP. And so we manage flow control between our source and target using these two processes, export, import. And on the target side, once we receive that message via import, we put it into what we call a post queue. And again, at this point, it is simply a change message indicating the type of change that took place, such as insert, update, delete, DDL, etc. And now you have a target database, and that database doesn't even know that it's participating in replication. It's fully up and available and functional. And the change messages are turned into valid SQL statements specific to that target. And we do provide the same read consistency as the source database. So as transactions come in, they're replicated by SharePlex, and you have two databases now that are in sync. And that's what replication is. Now, it's rather surprising all the things that this can do. Let's take a deeper look at some of these use cases. AI in action. So instant access and smarter data. This is a really exciting story. And as I said in the beginning, it's a bit like giving AI the instant replay. So traditional data ingestion with AI, it's limited to the most recent data only. It gets a glimpse of changes. Perhaps it's requerying the same objects on a regular basis or polling interval. And it can also be very resource intensive to ingest all the data in your database. Or you may choose to have a static point in time snapshot. And that's not going to show you much in terms of change visibility until the next time it's refreshed. And you might miss a lot. And it can be dated because if it's a snapshot, it's not changing. You're no longer suffering from extracting data from a production system, but it's out of date. It's not a great approach. Now, SharePlex, on the other hand, using the change data capture ability, is able to turn every transaction into an insert. So what? So what this means is that you have a complete history of the data. This includes, for example, those transactions that commit versus rollback. It'll also include a before image of the data. So if an update takes place, you'll see not only what the new values are, but also what it was a moment ago. This is an extremely low overhead approach, and it can be granular down to particular tables, particular columns in those tables, or even rows that have conditions for filtering what is in fact replicated into this change data capture. And the last piece that's worth mentioning is that we can apply PL SQL routines as a part of the connections that our post process makes to the target database. The so what is this? You may be wanting to replicate a database so AI can process it that contains confidential data. So format preserving encryption, there's a great NIST SP800 standard on this, can keep the format of the original data yet encrypt it for anonymity. So by using SharePlex, you get a few different things with AI. First of all, the AI is able to see every single change in terms of when it took place and what that change was. And that's what we mean by the instant replay. That's valuable contextual information. Now, in addition to giving you the complete audit and history of transactions, we also add some metadata, which I'll be describing in a moment. But let's consider the case of a sales order or sales quote. For the first request, it's actually 3 products: Toad for Oracle, Toad Data Point, and TFM. Now, in this case, it was quantity 10, 4, and 1, and very simple from a database standpoint. We see here on July 2nd, insert, 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 commit, and you would see all of these values as well. Now, an announcement was made where Toad for Oracle now combines and includes Toad Data Point. So there's no reason to have this particular SKU. Depending upon how the application works, here's some DML that might run to change from this being the quote to this being the quote. We have some updates, a delete, a couple of more updates. You'll notice in each of these updates, we're recording the before and after image, and finally a commit. Now, finally, the third request comes along and says, well, we don't need TFM, but please make the quantity 20 for the combination of Toad, Oracle, Toad Data Point. And again, we see the required DML to do this. It gets rid of line 2, and then we see an update in terms of quantity, both before and after image, as well as commit. So if you were using snapshots or you were pulling from the database, you might just see this final order with no history. Or you might see this first request if it's a snapshot, and you might see this third request, whereas using SharePlex cuts down dramatically on the overhead to get this data, as well as giving you this complete history, which allows AI to run what I'll call the instant replay and provide the most insightful capabilities available. Now, I mentioned metadata. So these are the columns that we add. Some of these are self-explanatory, such as the source, time, user ID, the type of operation. I've mentioned some of this, such as insert, update, delete, truncate, etc. We also contain database information such as the source SCN, the row ID, a sequence. And then towards the bottom, there's additional information about what is the host, a SharePlex queue name, as well as source ID, which you can define, and a change ID. This rich metadata is answering who, what, when, and where, in addition to the instant replay capability. Again, the effect of this is your AI's capabilities are only as good as the accuracy and completeness of the data. This is as good as it gets, and it's extremely low overhead. Let's talk about our next use case: reliable scalability and availability. I was actually a SharePlex customer before I joined Quest, and this is the reason we purchased it. We had an Oracle e-business suite, and at the end of the month for our financial close, we would run a GL trial balance report. And we were now mixing these GL trial balance reports, which traversed millions and millions of general ledger entries, against online transaction activity or processing, OLTP. Now, OLTP is much different than reporting workloads. OLTP is small, but numerous transactions. It might be people entering orders. And if that slows down, you're literally impacting the productivity of all the people using the system. So the challenge becomes, how do I run these reports, which are required to do my closing, at the same time without dramatically impacting and negatively impacting, slowing down the work of so many users? Now, it's not just reporting that can slow things down. It's any workload which is very intense. It might be an MRP run. It could be other sorts of extracts. But here's the beauty. When you use SharePlex, if we look up here, we have the ability to keep a replica database in sync in near real time with the source. So rather than mixing the OLTP and reporting activity together, instead, we can isolate that workload of reporting. We'll have that same data available here because of replication. And we simply point the reporting aspects of the application to the replicated database. Now, the impact of these reports only occurs on this target database and not the source. So what you can do is you can relocate and isolate workloads that are disruptive. Now, this is the simplest setup. And I've often heard from folks where they become a victim of their own success here. And what I mean by that is I've visited customers who have purchased SharePlex for reporting. And then they say, well, it was great when we started, but it's really slow now. Well, the reason is the reporting activity has grown so much, it actually slows down the reporting database. And this is where, if you look at these two additional architecture diagrams, in this case, we only had a single target database. Down at the bottom, we're broadcasting that same data out to 3 different targets. So instead of having just a single instance to run reports against, the reports can run against here, here, and here. And you may choose, for example, to run certain reports in certain instances. And as was described with the AI, we have the ability to select certain objects, even certain columns, and then certain rows based on conditions. There's no distance limitations, so this can be very helpful, for example, if you're needing to replicate data and make it available locally to people. So this is a quick overview of how SharePlex is used for scalability. Think of it as the ability to divide up your total workload and distribute it across databases. There's much more to tell, and I'll touch on that briefly around scalability and some of these other use cases. But let's move on to the next one. So, availability via SharePlex. Imagine, there's really two types of outages. One of them is a planned event. And this is where you're doing maintenance on possibly your hardware, the operating system, database, or even the application itself. This is known about ahead of time. Or you may have unplanned events. It could be a power failure, which is widespread and extended. Interestingly enough, 10 to 15% of data center outages are caused by UPS failures. So while the power from the outside is working fine, and you may have redundant feeds and so on, if your UPS fails, you don't have power to your system. There's also the backhoe fade. I found out this is an official term, and it has to do, and it occurs particularly in urban and suburban areas where there's a lot of growth and carriers have co-located fiber together. So there's a lot of different reasons for unplanned outages. Now here's how SharePlex doing database replication can help. First of all, as was mentioned, what is replication? We have two databases that are completely open, up, and available and running. So if the primary database goes down, simply point users, or the applications rather, to that failover database. Now, in the case of a planned outage, maybe this is for migration, patches, upgrades, etc., you may run your users on this system. You can keep this target database up to date. Then you can pause the replication, upgrade this instance, then tell SharePlex, go ahead, continue replicating. It will work through the backlog of transactions. And then once these two instances are up to date, you can switch the users. So all the work that was done here, which normally is an outage, the only outage that needs to occur is when you switch the users from one instance to another. And so with replication also going back the other way, you now can upgrade what was your primary instance. And then in a similar way, you've stopped and you'll resume the transactions. This will bring this database up to date. So the downtime becomes how quick can you switch your users from one system to another? Plus, there are so many benefits to this. Users can go in and test against that target database. This is great because they see what it's like before the cutover. Now, this last use case, active-active load balancing, I want to point out a few things. First of all, you'll see there's 3 databases, and these arrows are bidirectional. That's because it's what we call active-active replication. And some users may connect here, others may connect here. SharePlex is smart enough to know whether it's a user transaction or something from replication. Only apply that once to each of these databases. And what can happen is you may have this database fail, whether if it's an unplanned event or perhaps you're needing to do maintenance. But this is the most comprehensive solution, active-active, for availability. We've had customers who have done zero-downtime migrations using active-active. Now, why doesn't everybody do that? It's a lot more work to do so because you have to take care of something called conflict resolution. So know that you've got tremendous choices and flexibility to maintain availability using SharePlex. Now, with database migrations, it's hard to believe, but customers have told us that by using additional technology, SharePlex, it actually reduces their effort by 40%. How can that be? The reason is quite simple. If you're doing a migration without something like SharePlex, what will happen is it becomes kind of a command performance, all hands on deck. It's rehearsed numerous times. It's optimized to fit in the migration window. Think of it as practice, practice, practice. Because when it comes time to cut over, the risks are quite high. What if you don't make it? Then you have to tell the business, well, we're going to migrate this past weekend, but we didn't get it. With SharePlex, it's completely different. You can decide when you start the migration. You can decide when you cut people over to the new system. You can start the migration during the day without any downtime. So think of it as, instead of the schedule controlling you for a command performance, you only have to do this right once. And SharePlex gives you the flexibility to start a given part of it over and over again. But once it's right, you're good to go. You can move on to the next piece. It's not practice, 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 and optimize. And again, customers have told us this saves up to 40% of their effort. Those were some pretty wild claims. Let's take a look at an actual database migration with SharePlex. So on the left-hand side, we've got a current production system. On the right-hand side, we've got a new production environment. It's empty. There's nothing in there. So users are running on the current production system. We install SharePlex and we tell it to replicate the data, the changes coming in, as far as it can, but without putting it into the new empty production database. So as transactions come in, those transactions not only go in the current database, but they're accumulating on the right-hand side in the post queue. So at this point, it's a matter of instantiating or seeding that new production database. So it doesn't matter to us how this is done. It could be a backup, snapshots using disk technology, could be RMAN, could be export-import, data pump, you name it. The important thing is that you know the point at which that backup from prod was done. In the case of Oracle, you'll have an SCN. In the case of Postgres, you'll have an LSN. Now, with that information, this database here is built. But of course, the problem is that it is out of date. And this takes some time to accomplish this process. Now, fortunately, all the transactions and a little bit more that are missing from this database that are now in here have been accumulated in the post queue. So you can release your post queue. Now, up until now, actually even including now, there is no outage. So the users have just continued to run on production. We issue a reconcile command, and that looks at the incoming transactions based on either the SCN or LSN and says, oh, this is already in there. And finally it gets to a point where it's a new transaction not in the database, and it begins to apply these. Works through the backlog, and now you've got your new production environment in sync with your current production. You still have not taken an outage. This is the point where users can begin to test the new production environment, and you can migrate users over. Again, you choose when to do this and how long this takes. Again, the big benefit here, besides dramatically reducing downtime, is the fact that it's no longer this command performance. Huge reduction in effort, 40%. Now, I didn't mention that you can also, during this migration, replicate back the other way. This is significant because if there's something wrong in the new environment, that's okay. SharePlex gives you this insurance policy. In the event that the new production environment doesn't perform as expected, users can fail back, and all the data that was entered in the new production environment will be in the previous or current production environment. So a lot of benefits: reduction in downtime, elimination of risk, and reduction of effort. And that will occur regardless of what your planned activity is. Let's look at migrating databases made easy. So we've talked about these planned events. Let's talk about unplanned for a moment. Generally speaking, a business continuity plan will establish an SLA with the business around two key metrics. One is RPO, or the recovery point objective, and that simply says, what data will I have over on my target system when we fail over? The other key metric is recovery time objective, and that is, how long will it take before I'm back in business? Now, as mentioned, when SharePlex is keeping up the delay between the source and target, it's near real time, typically just a few seconds, anywhere from 0 to 2 to 3 seconds. So you have a database which is fully up and available. You've got very low, not zero, but very low data loss with the recovery point objective. Now, SharePlex doesn't lose data unless the source database is completely non-recoverable, in which case only the transactions which are in flight are lost. And so that database is already up and running. So if you think about recovery time objective, the typical steps, mounting, recovering a database, are no longer needed. And this can offer one of the fastest recovery time objectives for unplanned events in the business. Availability for application upgrades. We have helped companies maintain availability while they've upgraded their main business application. Now, this is complex, but it can be done. One of the things you need to do is to restrict the business to only the critical functions in the application. So it's not going to be business as usual. It's only going to be those transactions which are critical. You'll need to analyze the schema changes as well as any underlying logic that goes along with them, and then code and test PL/SQL routines for these revised transactions, which have changed with the new version. Now, we did this for one of the world's largest logistics company. They were using the logistics module inside of Oracle e-business, and we kept them up and running with the logistics module while they upgraded Oracle EBS. Again, this is a lot more work because of the potential schema changes that only occur as part of an application upgrade. Huge benefits here across the board for both planned and unplanned events. Now, let's talk about our ability to integrate data. This diagram is showing an awful lot, but I want to emphasize a few things. I mentioned the idea of change messages. I didn't say SQL until it gets to the very end. Now, because of this, when we write to the target, we don't care if there's a difference in the version of the database, a different operating system, a different addition to the database, because we will translate that change message into the applicable environment. Down the middle column here, you see a number of repositories. And I've got a chart on the next page, and it groups into posting between databases, streaming technologies, and files. Let's take a look. We can source data from either Oracle or Postgres. It doesn't matter if it's in the cloud or on premise. You can see here's Oracle in the third column, Postgres in the fourth. And these are all the different target databases that we're able to write to. We also can post data to what I call data streaming, things like the Azure Event Hub, JMS, Kafka. And then finally, file output, JSON, SQL, XML. We support Avro, as well as Parquet in our upcoming, it's our intention to add Parquet to our 12.1 release. It's in beta being tested. So exciting where we're going and also the capabilities we have here. But if you need to get data out of Oracle or Postgres and into any of these target databases, know that SharePlex will do this in near real time with extremely low overhead. Because again, we're reading the changes from the online redo logs or WAL files. It's efficient and low overhead. SharePlex has been around a while. It was more than 25 years ago now that the company I was working for purchased SharePlex. It provides low latency, high volume for mission critical systems. And the reason we make such a big deal about this 25 years is that you get exposed to an awful lot of environments in that time. We invented Oracle replication. We've been at it the longest. We've probably seen more in this space than anyone else. And it truly has led to a highly reliable mission critical solution. So why do customers buy SharePlex? Well, one is the reduced cost of ownership. This is the combination of subscription along with the operational costs. It is simple and easy to use out of the box, relatively speaking. We've had customers tell us that they were using other solutions. They would have a senior DBA assigned to it. It would be a full-time job to keep the solution up and running. They've also, that same manager told us that SharePlex allowed a junior DBA to manage replication on a part-time basis. The beauty of SharePlex comes from a design going back more than 30 years. SharePlex FS is the root for SharePlex for Oracle. We took the beauty and elegance of that product and we built SharePlex for Oracle. Now, we do have some differentiated product features. We are all inclusive. So rather than needing to go out and buy multiple add-ons, things like compare, repair, conflict resolution, monitoring, it's all built in. We pride ourselves on our technical support. They are truly award-winning. And lastly, I'll mention another capability that SharePlex has, something we call optimistic commit. What this means is that we don't wait for the commit to send the transactions across. As they occur, we'll send them across. If they get committed, we commit. If they get rolled back, they get rolled back. Other technologies have to wait for the commit before even transporting the changes. With large batch jobs, this can lead to serious latency between your source and target. Not so with SharePlex, because we move the transactions as they occur. Data integration. We've seen some of these architectures. I mentioned the change history along with the metadata repository. So for example, those source columns like who, what, when, where, in terms of who's making the changes. I did show broadcasting of data from one database to many. We can also consolidate many databases into one. In this last use case, this part of the diagram is meant to represent PL SQL. So yes, you can actually transform the data as part of the replication process. Very powerful feature. And it's that piece that was used to maintain application availability during an application upgrade. Lastly, if you have any questions, happy to take them. I really appreciate you attending today. Again, my name is Bill Brunt, talking to you today about SharePlex from Quest Software. Before we get to questions, though, I want to tell you about our next session, which is going to take place August 6th. I started today's session by talking to you about the four main use cases, and that we'd be doing a deeper dive into each one of these in subsequent sessions. So August 6th is where we take you even deeper into the AI ingestion use case. Hope you can make that session, and let's get into any questions you may have. Thank you.